Hello everyone, hello Manush. So this is a quick demo for the libp2p V4 swap agents that I've been working on for the past couple of weeks under the leadership of Manush. So this project basically demonstrates how decentralized P2P agents can coordinate on-chain operations using the Rust libp2p library for peer-to-peer communication and the Uniswap V4 hooks for on-chain swap tracking. So without much ado, let's quickly get into the demo. So we already have two pairs. We already have a network running, and we have two pairs in the network. Okay, so let's be sure everything is working fine. Here. Okay, so we get the message. So we send a message. We sent a message from agent A, and we get it in agent B. So for this demonstration, I'll be showing you the simulation mode, the local alongside the local MV integration, which using Foundry. Also the swap intent gossip with the pending swap pattern, and finally Filecoin Archival using the Synapse SDK sidecar. So right now we're in the simulation mode, and we can check the commands at our disposal by simply typing help, and we can see we have a number of commands at our disposal here. If we type in sim, we'll see that we are actually in the simulation mode. So basically, the simulation mode lets agents coordinate without blockchain interactions. Perfect. This is quite perfect for testing P2P logic without spending gas. So yeah. So remember, we have two pairs in the network, which are actually listening on both the TCP and the QUI transport. So these two agents connect and discover each other via MDNS, and they automatically exchange identity attestations. So let's quickly make a swap. This video is getting quite long. So we're using the version, the V2 of this entire setup. So yeah. So we can see the intent to swap was broadcasted to the network, and we're swapping token A again. We're swapping we're swapping token A against token B, and you can see the simulated transaction hash, and we get that over here too in agent B. You can see the timestamp, the simulated transaction hash, and all that. Yeah. So first of all, we see, like I said, we see the intent. Then the swap is taken. Then the swap with a synthetic transaction hash, and both agents see the message in that particular order. So this is the pending swap pattern, ensuring intents reach the pairs before execution. So the pairs see the intent first before the transaction is executed. So we can switch over to MV now, so we can test. So I forked SEPOLIA locally, so we can execute reswaps against actual contracts at zero cost. We're actually using the localhost 84. Let's see. Yes, 85 85445, and instead of the SEPOLIA ROPC, so we're using MV locally instead of SEPOLIA. So this is a swap executing against the forked PoolManager contract and the AgentCounter V4 Hook. Okay, so basically we can query. So basically we can query for on-chain state. So we have the swap executed and a base fee of 0.30%. So let's quickly make a swap. Should have done that. So we're swapping again. The pending, you can see the intent is broadcasted first, then it's being executed, and yes, the second agent picks it. Let's wait for that to take place, and I'll quickly explain the swap intent gossip and the pending swap pattern. Or let me just go ahead and explain that. So the swap has been completed and it was successful. So remember, this basically gives us a production grade testing without testnet costs, just to make it simple and simplified, without spending much on testnet. So for the swap intent gossip, we can now, the intent gossip the intent commands actually broadcast a swap interaction with the amount, you can see over here, with the amount, the direction, and the price bounds. So for swapping from token A to token B, or token B to token A, we specify. So let's say intent CB, okay, the price bounds, and yeah, so it will be broadcasted to the network. Again, B picks it up. Okay. Yeah, if we want to swap, same pattern we'll be following. It broadcasts first to the network. It broadcasts first to the basically every swap command is automatically broadcasted first, like I made mention of earlier. Then it pulls the swarm for about 400 to 500 milliseconds. I'm not quite sure right now. Then finally flushes the message before executing the swap. So this is the pending swap pattern. Okay, so we want our swap to be broadcasted first to the network before the swap actually takes place. In a subsequent iteration, we'll work on the other agents agreeing on the swap that's to take place. Then finally, what's the next agenda? Let me see. Yes, then finally, the Filecoin Archival. So the sidecar is already running at port 3001. So it swaps the Synapse SDK, which is TypeScript only, and it exposes a clean HTTP API for the Rust agent. So already we can test locally too, but it's preferable to test in live network. But for now, let's just test locally. So let's say okay, first of all, let's quickly explain this. So we have executed a number of swaps prior to this, so we don't necessarily have to execute any swap again. But let's say this particular log status commands, it shows us if we have any entries buffered locally, which is ready, any entries that are being, any swaps we have taken before, which is about 3. So look, oh my god, I'm losing my train of thought. So it shows us if we have any entry buffered locally, which is ready to be archived. So if the archive command, hope I spelled that there. The archive command sends the buffer to the sidecar, which uses the Synapse SDK to store it on the Filecoin calibration network. So let's just quickly wait. That might take a bit of a minute or two. I can pause this video. Let's just wait, and it will send out the command and we can view it. Just a second. So while we're waiting for the response, let me just explain what comes next. So we get a piece CID, that is the Filecoin content identifier. The output basically shows three ways to retrieve the retrieve command, the browser view URL, and the raw API. So the retrieve pulls the data back from Filecoin and displays it in the terminal. We can see the swap execution with the transaction hash, the agent address, the token amount, and also the time swaps. Then the browser view, we can just open the browser. So we can open the browser and view it, which is a formatted JSON showing both swaps. It's showing the both swap logs and the identity attestation. So basically this data is now permanently archived on Filecoin, creating an immutable audit tree for basically dispute resolutions and trust scoring. So we can see it over here. So let's quickly head over here, and you can see the CID. You can see it. What I'm waiting for. So yeah, that is it. Thank you for the patience. It was a long one, but thank you for the patience. And any further questions, I can always answer. So this is just a summary of what I've been working on, and I will try to add some links and some documentations to this video for further readings. So thank you.